Okay, we're entering part two of this, and the way they've got it set up, I can't even put the old ones and the new ones in. Haven't figured out a way to add that in yet. For some reason, it doesn't show up on my thing to where I can do it. So hopefully, I'll have it figured out by then. But if I don't, you're just going to have to go to the next one. I'm going to release these at the same time so you can watch them in order. And I'd hate for you to have to go back to my site and click on it and then just go to videos and go down and go, oh, here's one. Hey, I didn't even see this one either. But you might do that. So anyway, what we were talking about here is how people through time had figured it out and lost it, and figured out and lost it, all the way from the ancient times through Platonic times, through Leonardo da Vinci, and then they'll show you that here it is again, what they say exactly. This was rediscovered by Johannes Kepler in 1608, and yes, that Johannes Kepler is the guy that they finally so the sun is in the center of everything in Copernicus. Well, he was working off Copernicus's astronomy, epitome astronomy Copernicus, in his stuff, and he basically was proving that the guy had figured it out, and he did it even with more math and more things and everything, to the point that it was like undeniable. And then, but you can imagine the fit and the problems. For you weren't even supposed to be studying this type of thing, you know. They acted like you were trying to find the finger of God, as I was saying before. And man, I realize this is a long, drawn out thing, and if I was to really do it right, like sometimes I read the whole thing, if I did that here and started talking about math, I'd get some snoring going on and people clicking off. And so I'm going to try to keep this going and have a little bit of fireworks to go along every once in a while. So if you do click and go through it, you're going to miss it. You won't know, but just 30 seconds ago I said something that's real cool. So hopefully I'll get you to stick with me. Not that everything I say is cool or anything. So let's go ahead and let's light off a couple of fireworks here real quick. So they said that they'd refound it over and over again, and I'm about to show you, and I've already told you that of course it goes back to pyramids and all that, and they talk about the pyramids having this effect here coming up, and we're going to get to it. But I don't know, let me light this little firework off here. You know, the word for Jesus and what he was, and everybody says, oh well, Jesus is a carpenter. You know that, right? You know that Jesus was a carpenter. That's what it says in there. But what's funny is if you look at the Greek Septuagint, they give the word tecton. And boy, doesn't that sound nice. You know, tecton, that sounds real modern. Even today, that sounds like Tecton Industries, right? Well, whenever you get into it, and there's one other place that's described, and it gives another word, and God, I can't forget off the top of my head what it is. But those come out to be words that actually mean Masonic things. And not that he was a stoneworker or anything, but almost to the point that he was a person that had the sacred knowledge that could lay out a building. And they lay it out with these things and this sacred geometry and situation. They don't use this formula that we're talking about right now. This is just one part of it. This golden ratio is there's a silver ratio too, guys. Yeah, this is going to be a long thing here going through it, but I want to go through it so you can get an idea of how much onioned up crap that they had going on and how it's all built into religion. Now, this is all religion stuff. I know you know it all as being science, and science found validity for the things that were in religion, believe it or not, and it's ended up coming into there. So, boom, Jesus was a tecton, pow. Here, let me do one more before we go. Where's this dice again? I'm gonna hit you with the dice again. Sorry. What color would y'all like to look at? Let's see. Let's look at the rainbowy green, purpley thing. That's real cool. Tarnished. Ooh, ancient, tarnished. Magic dice. So, one thing I didn't tell you about here, because I want to keep enveloping and going back through it, but I'm going to literally show this to you again, but I want to hit you with it here, and then get you another firecracker, and keep going on to it. So we've talked about these different guys, different sizes, percentage chances already, right? So that's one knowledge of all this is percentage chances of what it can do, and that's just on sides it could land on, which if you think about it is sides that can face you, sides that can face another, and knowing that this side is flat on top and the one on bottom of that is flat too, not on the pyramid, but like even on the 20, the 6, even on a 10, on a 12, they're flat on top, flat on the bottom. If you were going to try to make a rock that was square to some size and fit, even polygonal, but we're not going to get into that, and you wanted it flat on this side, flat on that side, this would be a way to accomplishment. Just like you would take and cut a diamond or a jewel and make it look much like this right here. Ding! The facets, they're on a jewel, but it has a face, facet, face, and you'll have the face of the diamond as being the major part in the middle, but you'll have it chipped all around it, and that's done in sacred geometry too. Why? It focuses it down into it, and if you think about it, it's multifaceted like this 20 dice, but around the edge of a diamond, but the bottom side of it is faced like this, and due to the refraction properties through glass, in prismatic effects, you get it to reflect back more light if you do it that way, and the diamond gleams, but it's really little mirrors flash at you. And there's a whole thing to that, guys. And then, so the geometry of the way the light goes around on the inside of it, but then comes out, there's a whole geometry to that too, where you can figure out, okay, if ding, 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 zing, and it goes out here to wherever, and you can figure for that point. But I was going to show you this. So let's look at these shapes right here. For if you take this guy and his inner angles that are here, that are on it, they're 60 apiece. And a lot of people said, well, that's 666, and there's a pyramids and da-da-da and everything. Yeah, it means something too. Man, I could go off in left field. But let's just go this way. So that's 666, but that's also 180 degrees. So while you think 180 degrees is halfway around a circle, or halfway around a planet, and this is sitting in the geometric center of the land, it starts to, you get these things that just like, what? And it starts to show them like, how the hell they know that? Well, I'm fixing to show you, well, not right now, but fixing to show you that they knew the size of the earth, and then I'm going to prove to you. But I've already done that in a couple of other videos. I'll show you where it is in other sacred architecture, and whenever they marry the heavens and the earth and do all these things, how it's the sacred geometry that's held into it. Only some people knew about this stuff. And so if you ever took over and screwed those people over, you'd end up with a handful of dice and wouldn't know what the hell you were talking about, and it would look like some kid's spirograph designs over here on some papers and some dice, and you want to know what the hell's going on here. What the hell's a plutonic solid? They were playing games. What were they playing? D&D? Right. So let's just go through this real quick. Well, I don't do nothing real quick, people. That little fucker right there, that's 180 degrees that we figured out on the inside of that, right? So you could draw down these little pictures on one sheet of paper on one line in each one and start writing out next to it, but we're going to want to have a cheat sheet later for things too. But if you got a tablet, you could always do this. There's a triangle, and that equals 180, right? But there's something sacred too. Here's another facet. That numbers in ancient times, especially long numbers, they cut down, and they could even make them into a letter, right? Corresponding letters, and could use that even in codes and things along that line, and transpose this information to other people with a code bullshit that looks like it goes with some dice thing and some swirly papers, and you wouldn't know what the hell's going on. But they might study it in ancient Alexandria and figure it all out. And people, oh man, I wish they still had that. Yeah, we all wish they still had that, but it wasn't the fact they lost it. There were copies of most everything that was in there that was all still going on. They lost it for another reason. That's more of a history lesson, and the end of Rome and bullshit that happened out of it, and people not understanding what they're looking at, and they had a handful of dice. So these sacred numbers never go above 10. 9 is the godly number. It's the finish of things, the 3, 6, and 9. And so if it goes above 9, you add them back together and you develop a number. And so we figure out that these are all the symbols and the fingers of God, because if you take that 180 there that we just talked about, 666 and the 180, 1 plus 8 equals 9. That's God's number. It gets worse or better depending on how you want to look at it. So if we look at a square here, the cube itself, on a square, ironically we find that the degrees of angles equal to 360. Have you ever heard that number before? Well, the ancient Sumerians knew that the world was round, but they squared the world. And so whenever they showed it up on math things, it showed up as having 4 corners. But that wasn't the way they drew the earth, and how they got those 4 corners was from drawing a circle. And they knew the world was round, for we use 360 degrees for a circle, and the sun falls in its angle to us 1 degree per day till it reaches its lowest point near the sign aimed at the Southern Cross, and it kind of stays there and wobbles for 3 days and then comes back up and saves all mankind again from going into another ice age. Doesn't that sound familiar? But it's 1 degree per day of 360, so they'd already figured out all these concepts in it. And people say, well, it was the ratio they figured out on the arc that's on the moon whenever there's an eclipse, and figuring out how big the ball would have to be and all these things. And sure enough, whenever I show you how they figured out how big the moon and how far everything was away, was amazing. But we've been talking about Celts here lately, and Caesar himself, whenever he went there and talked to him and everything, he said they know much about this and this, the stars, the size of the earth, and da-da-da, and all these things about it. They already had this all going on. Oh yeah, Stonehenge is built on sacred geometry. We'll get to there later. I'm trying to get past these shapes here, and I'm only at square. 360 degrees, but that's the inside geometry of a square, and you can square a circle. So you take a circle and you put a square around it. What are the angles of the square? Because you can't show angles of a circle, because it ain't got none. A circle works different, and it doesn't work off phi, it works off pi. And these ancient symbols actually are the same symbols they use for gods too, by the way. And things like theology and just all kinds of stuff. So it showed you, yeah, sacred geometry. But that 360 degrees right there, 3 plus 6 plus 0 equals 9. So what about all these other ones? Well, what about the guy that has little pentagrams in them? Well, a pentagram's 540 degrees. What? Yeah, 5 plus 4 plus 0 is 9, and it's God's number. What? Okay, the stop sign shape. Stop sign shape, you know? There's not a dice up here with the stop sign shape on it. The stop sign shape itself is 720 degrees. 7 plus 2 plus 0 is 9 again. Well, what about an octagon? Oh, I'm sorry, I misspoke. This is that's the reason okay. An octagon. 8-sided. What's that thing? It's got 900 degrees in the center of it. And if you check it out, there's an increment of what these are raising up to, but they all seem to fit with sacred numbers we all know real well. And you'll see these numbers repeating themselves too, but 9 plus 0 plus 0 is 9. And if we get a decagon, which is represented here like this, but represented in a different way than the others, and both of them show 1,080 degrees. And 1 plus 0 plus 8 plus 0 equals 9. I'm going to grab a drink. Let me bump this. So, Now all of a sudden we start to see something funny going on with this golden ratio, and what's been hidden in the black for a long time are these numbers that fit the facets, just like this. Facets with numbers, percentages, and things that go on. So that's the math that we know. But it goes in lengths of lines and things like that and works with geometry too. Okay, that sounds neat. And every single thing on the planet has got it in them. Not that everything is everything, no. You could sit and find ones like that, but it's to the point that it's like, no matter what, I mean, DNA has sacred geometry. People have figured it out. There's a whole video I watched where this guy was doing it, and it's pretty boring. It's one of these guys that like that whenever he talks. But at the same time, yep, straight up. And you'll start to see numbers like that repeat over and over again, with that 1080 being based on tens, not on sixes like the Sumerians. And some people took that Deca because of what it symbolized and thought it meant everything, and then gave us our 10 base. That's why we have that, unless the Sumerian ones, because if you look at our hours and everything else, it's all still built on it. But that 1080 has to do with the 28-day cycle, 280 days of gestation, and all kinds of things that fit into that sacred number. But really, I just don't want to get into yet until we get the idea of what's going on here totally. But hopefully you caught on that and the other part of sacred. And I'm going to keep doing this like onions with these damn dice here, because it can go to another level. But we've seen these dice and talked about it enough now. Maybe I won't have to come back and show it to you next time. Because, man, this is getting long in the tooth. So all these people forgot it and then learned it and forgot it and learned it and forgot it and learned it. And I tell you, a couple of these people figured it out different mathematical ways. And they kind of show that coming up, and I ain't going to do that to you. But they talk about how they went through it, and then they finally placed the sequence 1843. It was rediscovered by Jacques Binet, who named it Binet's formula, and then everybody else finally figured out that it goes all the way back to here in the Pythagorean theorem. So what? Yeah, okay, and the Greek letter phi, and we've talked about this, Greek letter phi. Yeah, it didn't show the picture on that one, it's coming up. So architecture, and man, we'll just go through a couple of pictures here for a second. So they show some sacred architecture and percentages that go up, and how big arches are versus the top over it, and all these things. And somebody's figured out this whole thing is built on sacred geometry. That's nothing. You can go around and find that all day long, but this is just the one they want to show you. But funny how if we were to take it from there and chop it off, do you see a ratio and a look that looks like that ancient step period at Medum that we looked at? The one that's kind of taller and just goes duh, kind of looking like a lighthouse. Ding, sometimes light doesn't mean it, and that far inland, is it really about ships? And no, light is meaning knowledge too. What? You can get all kinds of knowledge out of light. So here's your famous Dodecahedron that I was saying about before, and so it's based out of pentagrams, but there are ways that you can set one of those inside another, inside of another, inside another, with a pyramid in the middle of it. And they show this all kinds of times inside of pictures and stuff. And the sacred geometry of an egg and how it fits the same proportions and works with the ratio, although not like chink, chink, chink. That's for crystals and things smaller and things bigger, but as the Great Pyramid here. And this is what you see inside these swirls of plants, like in the center of a sunflower, you see on a pine cone, or this one right here is from Abunum Forme, showing a spiral, which they call parastic. And this is a ratio we're about to show in a minute with a video that I was talking about, the first one, and showing a guy lay this out and how you get this, and you're looking like, what is that? Well, it shows you how to break down properties, break down properties and stuff, and even to the nth degree, and build a house, and I go into our room, but in my room we got the bathroom, but then we got the tub and the... What? Yeah, you can see it in there, but also this whole thing is a Fibonacci sequence and a swirl, and that's how you get it. And it may just come to you, this ratio where you go, well, I want this to be a little bigger than this, and about like this and this, and it'll come out something like this. And the reason is because the where you live and your mind is built on it and everything else, and it's all going around to it. And these people had figured out this sacred math situation, and it surrounds in them, and it's in the stars, and it's all the way down to something as small as the center of a little flower, or the eye on a bug, like the eye on a fly looks like a geodesic dome, right? And so here's kind of the fraction ratio where it's not quite it. It's 1.061092 whatever, but then if you start dividing to try to get it back to right, you end up coming over, under, and if you were to take this out to the nth degree, it actually just keeps going over, under, over, and it's never going to hit. But it gets closer and closer to the line, and then and is there a sequence, or is there a thing? No, it's not. It seems like it fades off. Comes out to be a different type of ratio. Alternately, people have said, whenever I hit a guitar string at certain notes that are actually built on this same ratio, I get this dong, that comes out of it, the ringing of a bell. And whenever you get a bell tuned, you're going to get these ratios to come out of them too. And whenever I say it's in the middle of everything, it's in the middle of everything. In the middle of music and all these different ones. And Debussy's La Mer, which means the ocean, corresponds exactly to the golden ratio. And Pearl Drums shows that their air vents on their premium models are based on the golden ratio. The company claims this arrangement improves bass response and has applied for a patent on that innovation, making sure that they use that instead of just slightly off or whatever. They make sure that they use it. Drums can be tuned, but then they've got that, and if you get it tuned and then hooked up to the old dam. Heinz Bolin created a non-octave repeating synth scale, or is this the other one? Yeah, on combination tones, using the features based on a golden ratio. As a musical interval, the ratio is 1.618. So it keeps working through. And man, do they have a second of it you can play? No, I don't want to download it. But in the same thing, it's a combination of tones. So he's using chords to make up situations whenever he does it, apparently. And you think that jazz goes off crazy, but if you looked at like little fractals going around that were based on golden ratio, and you picked random, you'd get something that was kind of jazzy versus something that you wanted to be real straight. That's the reason some people don't like jazz, is they don't like the occasional bulge or odd one. See, a tree should grow exactly like this, and while there's a golden ratio to everything, maybe there's a reason it didn't put out one right there. Happened a long time ago, and now he's got his arm over here and this, that, and the other, but everything's still in ratio. Anyhow, the golden ratio is a key to the golden section search. Dun, dun, dun. So this is breaking things down into thirds and everything. And I'm telling you that this mathematics of cutting a block up like they're talking about is something the Sumerians talk about readily in their tablets, about how they plot out lands and stuff. And when somebody dies and they got to give it to three of them, how they're going to cut it up and how they could do it. And if they got a big plot of land, and how they got to lay it all out and how they're going to do it. And they're going to give a whole people a bunch of stuff. And it can lay out for a big plot of land with little sections to it. that the littlest sections are acres, or it can go all the way down to a little house with a room with a bathroom in it, and there's a tub and a toilet, and it still fits under the same ratio. And here we go with that damn math and alternate ways of figuring and showing the same ratio. And if you want to know why I'm not going to get off into this thing, because this is the type of mathematics that they got all off into. Okay, do you see this right here? This is also the superioristic type times we find also these cosines and all these things that go on here. So what this has to do, and oh man, I could just go off on what I see right now, but anyhow, when you look at the thing, they talk about having a Sumerian, or what they call a Babylonian formula, and it's a whole lot easier than this. And we found out they had advanced trigonometry, and their formula is a lot easier than ours, more simplistic, easier to find the right number. And that's another thing that gives them a little bit of a problem there. But so they just decide they're not going to talk about it. So we see this shell, and I'm going to show you somebody in how they would make that using just a simple compass, right? But there's a lot of things that you can look at, and how you can get arcs out of things and situations. And so you've got a triangle here, and you pull it to that point, and from this point you hit that point and you draw an arc, and then you get representations of things. And they use this in sailing to figure out the best sails and things like that, different golden triangles and stuff. But yeah, pyramids, where are they at? Well, we're not quite there yet. So here's a pyramid, and it's bisecting point, and that looks kind of familiar to us, maybe like on a dollar bill. But if you were to figure out that 1.618 over that line would put it right up here, and cut that off, and then draw an eyeball inside that right there, leaving that section out between it, then you'd be more like what's going on, knock on wood. So here we got a pentagram. And to tell you one way that they hooked up goddesses with all these things and stuff, if you take Venus, which takes 8 years, and they quite often show her with an 8-pointed star, and you go, well, Venus is 5. Yeah, they show it for both of them, but then she's also a dualistic entity. If you took it, what it does, Venus, Venus pops up in our sky and goes away, and pops up in our sky morning and evening, and it plays peekaboo with us. At one time, some people thought it was two different things, and they gave it a here comes the good one, here goes the bad one, and all that stuff, because it heralded nighttime, which is bad, and then daytime, which is good, and all these things. And they were sisters. We've talked about this before, but so if we look at this, what would happen was it would draw, just like you when you're a kid, exactly, shing, 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 you would draw out that pentagram over that period of time. See that pentagon in there upside down? So we got that idea, and then here's this little concept, the whole thing, and it represents a star, right? Incredible. But Venus traces this out. Venus is a moving planet, and planets mean wandering stars, and they were special. They named all the stars and constellations and stuff, but these ones that moved around, they were making shit happen. They were the gods of old. In fact, they're still doing the same thing they were ever doing for any of these people. We've just kind of lost our little stuff about it that we had, and I'm trying to show it to people. So if you'll notice something here, they got a rainbow triangle that's facing this way, and it's kind of a squat down triangle upside down. It's a feminine symbol. And then if you look at the smaller triangle, it's squinched in and pointy, and that's a male symbol. And just like two triangles crossing each over makes the Star of David, this has the same concept in it, but it seemed to be feminine, dominant. Can you see it? But now to tell you, whenever I tell you that, man, this was in my face whenever I was a kid all the time growing up, and this album cover and this, that, and the other, and bullshit, and I studied about Venus, and then I found about this, and this goes with Venus, thinking, what the hell's going on? And that black triangle that's right there is the Star Trek symbol. And we just showed a video where live long and prosper has to do with a whole lot more in this stuff that goes on with what the hell? Well, just did a video series about hell and how that has nothing to do with the biblical idea of things anyhow in the first place. But we sure did keep some heritage that came all out of Europe and their concept of the same thing. And so whenever you think I'm destroying it totally, I'm not destroying it totally. I'm exposing it for what it is, and then it's all the same thing, and these people had this thing going on, and then they took exception to themselves, and they knew what you didn't know, and oh yeah, well, I know the Star Trek thing over here. I know that, and you don't know that. And I know, and ooh, woo, and whatever. And it got turned into a bunch of shit. Yeah, and we still use stuff that came out of this today. I ain't kidding. So here shows a representation how you can take a hex and you can get all these other forms of golden ratio out of the internal part of that. And what they're not showing is if you double this thing up and draw it out in that double Vesica Pisces circle, that's a seal of Solomon cutting across the middle of it, which is an incomplete if you draw it all the way on out, is a hex again, which if you draw that on out is the internal part of the Star of David again. And here we got a little star, boom, 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 and it starts growing on you. Word. But to explain that, it might take some math that looks like, what the hell is this? You know math's tough whenever they start using letters in it. And let me tell you, this is way past like x equals what? Right? To figure for this fancy ass things. But once you get it down, the thing that you forget is the theorems. Like I still remember that theorem 5-2 is that alternate angles are congruent and all these different stupid theorems that never really come into face, but hey, I remember it. So here's that Fibonacci, and we're going to look at somebody doing that here. How much time have I got? 32. Probably ought to cut to it here, guys, but so you see it in something like this, and you think that almost looks like something out of a video game, but this is micro and larger, and if you'll look, it's all micro and larger of the same thing, and that is golden ratio too. And so you find it in fabrics and things, and when I tell you things like argyle fabrics show it in it, and some of the stitchings and weaves that people go on for, you can see how you can make cubes out of it, and they pulled in, and sacred rugs with all kinds of designs in it and shit. And it's all based on ratios, and whenever they're using and they're weaving it in there, there's a ratio to how you make it go da 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 da. And that's the same thing too. And it makes things like this. And now we got pyramids. And it's got sacred geometry too. Let me get out of here just so I can show you that, yeah, we're down here at the other properties, and let's look at all this math going on. Oh my god. And then we have decimal expansion concepts and all this stuff, and oh my god. Yeah, but the pyramids, and here it is, and yeah, it's got the same thing in Pythagorean theorem. The right triangle is built into it, and if you use the right triangle into it, you'll, and people have seen this whenever the sun shining on it correctly, you can tell it's actually an 8-sided pyramid. There's a little dent in the middle right where that bisecting point would be at each one, and it kind of shows you a verifier in how they built it. And a second step, not only did they build it like that 4-sided dice, but that 4-sided dice was made out of more chunks. Well, if you really think about it, there's a couple of million chunks that are making this thing up too, and every single cut to make sure they were square blocks of rock and crap, even though they were kind of roughly cut for the center parts of it, we're using this too. But whenever they got down to it, the math got down to it, and it didn't just go to the point, but it went 1.6, 1 point to the thousandths at least, and people have verified this. To the thousandths is what they were doing. And so the ratio of the pyramid and the angle cut up that the pyramid has on it at angle is about 52 to 53 degrees. And they find out, well, if you cut that ratio out, it seems weird, but it's the slant height of the apothem of a 5:3, which is their ratio. 5-4-3 triangle is what they used. It shows right here. And they found this on the Rind mathematical papyrus. Let's see if it shows it. Yeah, ancient. Egyptian papyrus, but way in 1858 when they're figuring this all out. And it's at 1.666 times the semi-base. Just gonna let that sink in for a second. So it has another problem too. They have these racial scopes that go with it, and this, that, and the other, and the golden ratio, the Kepler angle, blah, blah, blah. People say it's close and it's this, that, and the other, but what it's even closer to, and I'll show you in the mathematical part that's not in this one coming up, where actually the size and shape of the Earth is there, and the amount that it's off that they're showing there is basically the amount of the bulge that's in the center of our Earth versus if you went from the top pole to the bottom pole. And that it's basically a ratio on if you went from the Tropic of Capricorn, like you had the Earth here as a circle, which I had one. Instead of going to the equator, I went down to the Tropic of Capricorn and cut across to the Tropic of Cancer. That's the point there. And what's wicked about that is that's the points that the sun goes at its maximum to in summer and winter on both phases of it, where it's summer down south and up north. And it's like, there's no way in hell they had that all figured out. It's like, no, it gets worse. Or better, whichever way you want to look at it. Stick with me and we'll show it. I wonder if I should get this guy starting to build this thing. Disputed observation. Everybody goes, oh, it's in seashells and nautilus shells and stuff. It's not actually in a nautilus shell. It would be if they kept the growth that was going right here and it exponentially kept growing. But it's less than that, and then it starts to do it here, but this thing would be huge if it did it and exponentially grow. And if you look right here, he didn't have a good growth in this last one. There's a couple of these where they don't, that one there, and so on. But this would have to be way out here for it to be right and start and keep getting the ratio. You see that there, they need to be more spread. Even though they're a little bit farther than the last one, this is just a snake shedding its skin and getting a little bigger. And they're not sure if he ever could get the ratio where it would get going to it. But they say, see, that's fake, and it's like nobody's talking about the part here that's the meat and those little fans in there. I mean, it'd be so incredibly beautiful if that fit into it. But we're just talking about this shape right here in the first place, and I know it makes its shell a little different than the ratio, but I can't control how that thing grows. Parthenon has it into it, and they argued, and they say, well, the pillars, when they go up, they get a little skinnier. Well, once you start walking up the steps to it, it looks like it's so tall because they do that Disneyland crap where they have tapered the top part of it just a little bit. And how much did they taper it? It's based on that ratio. But the whole building's based on the ratio, except for the part that they try to prove is not based on the ratio, and it's not doing it just to give you an extra perspective. There's a whole thing on how the Parthenon, that you think that it's straight, but every line in the Parthenon is crooked. It's not straight, and that's bullshit too. For all these little lines all over this thing, they're all straight as hell. What's not straight are these pillars that they actually taper in just a hair. And so if you were to get there in your eyeball and look at it, it kind of just tapers up. You can even see it now. Let's say it's 8 foot wide here at the base, and it's only about 5.5 here at the top of it. But we use that idea too. But their idea was that from a distance it looked a little cool but weird, but as you started to walk up the steps, this thing started growing. It was just like, for a reason. I'm not going to get to this guy's stuff because we're hitting 40 minutes. So you say, well, this isn't sacred geometry and this and all the way. No, they say this is all based on it. He basically got a compass out and flipped it around on the piece of paper and then started coloring in like you do whenever you're a kid, and then said, oh, I see it, and turned it into a whole picture that's here. Isn't that neat? Ratios again. There we are, cutting up plots of land in ancient Sumer. Like I said, Fibonaccian sequences and stuff, and it's how they build. rugs, and so much more. So all these things are looked at, and you can look at the golden angle. Let's see, the plastic number, sacred geometry. Ooh, we ought to go there. The silver ratio, and I don't want to spoil it for you guys, but they've got the super golden ratio. Dun, dun, look at that math right there, boy. Get it again. Look at that math. 29 plus 3 by the square root of 93 over 2. Word. People were doing weird, wicked math like this? Yeah. Well, were they using that? No, they're finding it in other ways, actually. This is other proofs of math, where it kind of proves the theorem onto it. And it's like, you can do it like this, you can do it like that. You can just take the triangle and you can do this thing to it, but then how long is that piece of rope? Well, if you're able to figure it out, like with a micrometer, it's 1.61 da 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 da. And how do you get it more fancy than that? Well, with a micrometer, you can't get no more fancy than you're going to get into the thousands and you start losing it. But if we get a piece of paper, you can figure it out to where it fills up the whole piece of paper. And all it does is start with 1 point, it never ends, just like pi. And we're talking about phi now. So you got pi, phi, tri gamma delta theta. Word. Oh man, so you could read all this shit and you actually wouldn't get everything out of it. I'm probably not. But who knows? Some of these books here would start describing how the ancients knew some stuff and then show you how that it ratios to the human body and the scale of the earth. But that's for another vid, guys. And I tell you what we're going to do right now. When we start this one, we're going to go to this guy that's going to build a golden ratio. See if it'll load right. And we're going to watch him build a golden ratio, and while we do, we're going to talk about it.
Tonight we're making some bacon wrapped green beans.
Bacon wrapped green beans. Hot damn.
Barbecue beef brisket. This stuff's gonna be delicious.
God damn, I'm gonna get hungry. I'm gonna eat something before I make the next part. But he shows you how to draw a golden ratio spiral. And he's got some music that's probably gonna flag. So I'm gonna stop it here. But it all starts with him making a little dot anywhere on a piece of paper and taking it, setting a compass, and seriously, at any amount, I mean, you don't want to go stupid, but at any amount, it's not like, oh my gosh, at any amount, and lock that thing down and make a circle and start using that same exact ratio that's right there. And then after we've done a few things, we start picking out points on the paper and that and other points and making it that wide. I'll see you on the next part. Peace.